Hello. Welcome back to the continuing lecture in return on investment. This is Dr. Jeff Holm, and this is the sixth video in return on investment. Actually, I was hoping to wrap up everything about return on investment. More specifically, the geometric average by the fifth video, but it had to run a little over. Fifth video had to end in a rush in like 30 minutes, so I couldn't quite wrap up the part about the R. And in the last class, I made distinction between G and R. They are basically returns, but what are the differences? And I said G is the case, growth rate is the return when there is only capital gains, right? In other words, in scenario one. But R is the rate of return in scenario two. In other words, in scenario two, there isn't only capital gains, but also incidental income as well. You remember that? So if we include this incidental income also into the calculation of holding period return and annualized return, the formula would have to be slightly different. Of course, I'm not saying that it's a completely different formula. It's basically this formula. But then, what's the remember when I calculated what's going on? This is not okay. Let me try again. Okay, somehow my Excel isn't responding, so let's try. Let me save this again. Okay, and now it's responding. Okay, and you remember that the way I calculated it mathematically, this one was calculated by Excel's built-in function, but it is not entirely by Excel's built-in function. I told you had to keep perspective of the algebraic, the mathematical structure of it, right? Some people, one thing you have to really watch out against is that complacence. That if I use this function, then Excel's. If I use this formula, if I use this command in Excel, then it's going to take. That's a very dangerous thinking. Why? First of all, it's like driving blind. Just putting it on autopilot. If you're a pilot, you put the plane on an autopilot, and just not really watching ahead of you. If you're a pilot, you have to constantly scan the environment, right? Scan the radar. You cannot just put it into autopilot. Okay. In other words, you have to have the understanding of the picture. You have to have the understanding of what's going on. Also, when you're driving, these days people are simply, so hooked up on this GPS, and they don't think. They just, wait for the GPS prompt, and then, you may miss the turn, or you may miss the intersection. A lot of things can happen if you just don't use your brains. Even if you're using a GPS, you have to have that self-awareness and awareness of the environment and the full picture, right? Complete picture of. So look, this is Excel's built-in function, but Excel's built-in function ends here, right? And if it ends here, it's the gross growth rate, gross return. What does that mean? Gross return is, think about it, between 2005 and 2006, the growth portion only is 30K, which is only 20%, right? But if you divide this by this, I mean, if you divide this by this, then it will give you 20%. But if you divide this by this, it's going to give you 1.2, 120%. You understand? It's going to give you, that is the gross return, right? Gross growth rate or gross return. And it's not the gross return we are interested in, because we don't want to express the, think about it. If your house value grew 120%, well, then people would people would be misled. They will think, oh, you bought it for 150K. If it grew by 100%, that would be now 300K, right? And then 120% would mean 360K. You understand? People generally 10% growth means 10% growth of $10,000 would be $1,000, right? 10%. People, in other words, in terms of net growth, right? We generally express growth or return in net concept, in terms of net growth, right? Not in gross growth. So think about it. If you want to convert and I told you this gives you this command gives you a gross return. But if you want to turn the gross return into net return, what do you need to do? You'll have to subtract 1. Makes sense? That's why we're subtracting 1 here, right? So that's why you gotta keep control of your own model. You cannot just leave it to Excel, right? And that means you need to know why and how, why it is like that, why it is and how it is derived that way, why it is derived that way, and why it resulted, and how it resulted in this model. Of course, we haven't quite covered how, because that will be discussed later. Why, how this formula came about. But let's see. When I calculated by formula, I did it like this. And what is this? This I14 is this term, 5.286. This is, and 5.286 is what? It's the product of all these gross growth rates, right? Gross returns. Product, it's multiplication, right? Product of all of them. So in a way, it's the result of compounding. It's the result of all compounding from year 1 through year 11, right? Makes sense? That's the result of the product of compounding everything from year 1 to year 11. So in a way, it captures the ratio between the first year house value and the last year house value in gross terms, right? In gross terms. So I said briefly, in the last video that since first year's first year's house value is the base, and base is always 1, right? Uh, and this is the total compounded result of the growth from gross growth from the base here. You might say, oh, how can it be more than 5 times? I mean, if this is 1, this cannot be even 5. This should be something like, no, I'm not, this should be something like 4 point something. No, look, we're not talking about only the, capital gains. There was also, right, rental income. Remember that? And altogether, the compounding effect is like that. So, but then, mathematically, I don't want to bring it too much, let's see, the mathematical reason behind it. So let me go to the PowerPoint, the slide again. And to do that, I will have to stop this sharing the Excel file and go to, okay, this takes time. Okay, I wish the switch is instantaneous, but there's a little, time lag or delay. So here, let's take a look at this slide. Now, you understand this is how we calculate the geometric average, right? Geometric average is, PT plus 1 over PT. PT plus N is the future value, right? This is present value. Now, and then if I can rewrite it also this way. I can explain it also this way. By definition, if there exists, that means there exists. That symbol, instead of spelling out there exists. And spelling out everything it's too time consuming and it's verbose. So math wants to be as simple as possible. As math hates redundancy, and math wants to be very compact and condensed. So non-essential expressions like there exist, we can just condense it with the if there exists a unique G growth rate, unique that means unique geometric average, right? Then think about it. All of this will simply collapse to, right, the future value PT plus N, which is originally PT plus N is what? PT plus N is PT times 1 plus G1 times 1 plus G2, 1 plus G3, and so on, right? 1 plus Gn, right, the last term. And if n is 11, n minus 1 would be 10, n minus 2 would be 9, right? So now think about it. If we found that average, right, then we will get the same result as this if we simply compound PT by 1 plus G and raise it to nth power. Isn't that right? If there exists, and if we found this geometric average, all of these G1, G2, G3 will simply turn into G. Make sense? Because it's an average, right? And otherwise, each individual growth rates are all different, and it's uneven. But if we found an average, the growth will be, we can replace it with even growth, right? Even growth rate year after year. Then it will turn into simply 1 plus G raised to nth power, and it will still be PT plus N, right? So you can make them equal. You can put an equal sign between the two. So the left-hand side is PT times 1 plus g raised to n. The right-hand side is this. Now, let's think about it. Math likes to make everything simplified to the reduced to the simplest form. And in this between left-hand side and right-hand side, we have a common factor, which is pt, right? And pt is the common factor. So even, we can cancel out pt because the ratio between the left-hand side and the right-hand side won't change, right? When you do the same thing to both sides. For example, you can multiply the same thing. If you multiply the left-hand side by 10, you must do the same thing to the right-hand side, right? So suppose this is 10 and this is 10. Now, before multiplying 10 to the left-hand side and to the right-hand side, there was already equal sign between the left-hand side and the right-hand side. That means before multiplying 10, they were already equal. Two sides were already equal. So then, whether you multiply it by 10 or not, the ratio between the left-hand side and the right-hand side are the same still. So that's why you can cancel out pt. And if then when you cancel out pt, then what does it become? It becomes 1 plus g raised to nth power in the left-hand side, and on the right-hand side is just this, right? Then if you right, because pt over pt is 1, you don't, you can simply and then suppose you want to solve for g. Well, what do you have to do then? What will you do? If you're solving for first of all, you cannot directly solve for g, right? You will have to first, solve for 1 plus g. And to do that, you understand, we haven't done time value of money, so this will be discussed again there. But just to get rid of this n, the exponent, you will have to take the nth radical on the other side. Nth radical means 1 over n, raising it to 1 over n. So, and then once you raise it to 1 over n, then just to isolate g, what do you need to do? You will have to subtract 1 from the other side. So this is what it is, okay? Then g equals, right? What does this mean? This means product. Product means, you're multiplying all of these terms, right? And instead of, when I multiply all of these terms all together, right? What do I do about the time subscript? Well, we have to use a representative symbol for time subscript. So I used I for that. I means individual, right? Individual growth rate. So you remember sigma is a summation symbol, summation sign. This is the Greek character pi, the uppercase, not lowercase. You're familiar with lowercase pi. This is uppercase pi. Pi stands for product. So you're multiplying everything from every g growth rate, starting with the first growth rate all the way to nth growth rate. So we capture everything in this just single expression, and then we take we raise it to 1 over n minus 1. So what is that? That's exactly what I did in that Excel, in that cell in Excel, right? So let me go back to Excel. So I'm gonna have to stop sharing, share, then All right. Add to Excel. I hope you are also. So this cell, this thing is keeping me. See what this is? This is what? This is the product. Product of all 1 plus R, right? Individual 1 plus R's product, right? And then if we have to find a geometric average, right? In this case, R, right? Average R, and then product raised to 1 minus N minus 1. Okay? So there it is. That explains, how we find the geometric average when we have additional income or incidental income. In other words, scenario 2. So it's not just the case where we have, it's not just scenario 1, but even in scenario 2 we can find. Now, you might think, you might feel overwhelmed already. This is just the first, this is the 6th video, so probably this would be like in the second day, second class. Already by the second class, you feel you're overwhelmed with math. I know this is very, very basic algebra. Okay, and you may at first feel overwhelmed and grilled and bombarded. But look, this is a recorded video, recorded lecture. And this video is available for 1 week. So you have plenty of time to replay this video over and over until you get it, right? In a way, this is the benefit of the online class, because in a face-to-face class, I cannot repeat this, because every class session, there is a material to cover, topic to cover, material to cover. If I repeat it, the next topic will suffer. Some students ask me questions, in a face-to-face class. Can you repeat that again? From the last class, I couldn't quite understand. To explain something like this, it takes up like at least 30 minutes to 1 hour. And the class suffers that much, because the next class will suffer, next topic will suffer. And if this piles up, by the end of the semester, we cannot cover the intended coverage or intended amount of topics that was originally designed, put into the syllabus. And everything gets delayed. Midterm gets delayed, quiz gets delayed, right? And if I do not feel, if I feel we don't have time to go over this, because our time is short and time is very thin, and we are, we have to rush. I cannot revisit the same thing over. I cannot explain it again. That's what, in face-to-face class. Of course, in face-to-face class, the students will have to come. You will have to come to me during my office hour with your questions, But then again, my office hour is also limited, and I cannot accommodate, as many people as I want, right? But look, in an online class, you can revisit this, right, over and over. and we don't have to, our next class doesn't have to suffer. So please make the most of it. No, in the spring semester, I made the videos available for only 48 hours because the class is synchronous, meaning everyone has to attend the class at the scheduled time. If I leave it on, if I give like 1 week, some people will never attend the class. They just report attendance and do something else, and there is no way I can monitor that. I can, but so I had to leave the window for only 48 hours. But some people even don't take advantage of that. So this summer, right, during the summer session, I leave it on for maybe not 1 week. The same thing may happen. Maybe 72 hours or 3 days, which is 72 hours anyway. Or, whatever. Okay. So make the most of this window I gave you. Okay. If you revisit it, you will be able to. So that brings us. See, this formula, you might find this, you must have found this very daunting, but now you understand what this is, right? This means product, right? The product of all 1 plus gi's, where I runs from 1 through n. So it's, sum of all of these should be equal to 1 plus g raised to nth power. And in this case, g is the average, right? Geometric average. And this gi is individual growth rate. Okay? And if gi is equal to gj, right? In other words, that means g is the average, right? Gi is like, I for all, that means for all I that's not equal to j. That means I is 1, j is 2. If I is 3, j is 4 or 5 or 6, 7, right? In other words, that means growth rates at different time period, like, year 1 and year 2 are supposed to be different. But if they are all the same, that means G is the average that makes all the growth at each annual growth the same. Then G can be solved by, right, the product of all those annual growth rates raised to 1 over n minus 1. Okay, this now that explains this daunting expression, right? Now that should explain, but at least if you understand at this point, you probably find it very difficult and overwhelming. But if you go over this repeatedly, over and over, then you'll get used to it. And by the time you get used to it, I mean, you should get used to math. You should get used to algebra to be successful in this class. There's no way you can be successful in finance and economics, right, without being at least comfortable with this level of math. Okay? And I told you why math is full credit. Because math requires the most brain power. It's not a joyride. Okay? Art appreciation, art history, those things are joyride. If you think about it, it's a joyride. It's an easy storytelling. Oh, Monet was, I visited Monet's garden, Monet's house in Givenchy, France, and beautiful paintings, And Monet, but you know, art. If you're art historian and if you're art history student, oh, Monet was relatively, you know, lived a comfortable life, blah blah blah. So he could, you know, uh, well, and you know, the fact that he had, you know, a happy life influenced his, you know, paintings. All these things, easy reading. What intelligence does it require? Huh? Everything story flows, runs so nicely and beautifully. Nothing to really agonize, you know, nothing to really like, nothing to drive your brain to the extreme. And there's no dispute, right? That's why math deserves more respect. That's simple, you know, simple and straightforward. Why all the rocket scientists are basically, you know, math genius. I mean, not necessarily genius, but you know, people who are good at math are the people who are opening the future, paving the road to the future. Art history is about the past. Okay. All righty. So that's it for this segment of the video. I will see you guys in the next video. All right. Thank you.